Hi folks, this is Tom. Today what we're going to do is take an electrolytic capacitor and reform it here on a Sprague Tel-Ohmic Model 6 Capacitor Analyzer. This capacitor is out of a probably 1940s Macintosh Model 5018 electroshock therapy machine. That's right, that's actually what this is. We picked this one up as a part of the prop sale from when they got done filming Grimm down in Portland, and this is one of the props they had. This is an 83 rectifier tube in here. What we're going to do is we're going to actually go through this and return this into operating condition. So what we're going to do is take the capacitor, put it on the TO-6 here. We've pressed the DC voltage for electrolytic leakage test right here. And what we're going to do is slowly run up the control here. And what that's going to do is it's going to put voltage on the Simpson 260, which is in parallel with the voltage going to the capacitor. So we can tell from here basically what the voltage is so we don't exceed the 500 volts. And the ammeter over here, we're going to be able to tell from it basically whether this thing is going to work or not. The problem is electrolytic capacitors have two poles on them, and if they haven't been used in a while, the poles, the materials on the plates deforms. So the worst thing you can do on an old piece of electronics equipment that's tube type or has electrolytic caps in it is turn it on after decades of non-use and expect it to work. So what happens is the plates deform and all of a sudden kablooey. That's what we want to avoid here. So what we're going to do is in a controlled circumstance with this, we're going to control the voltage and the current going to the capacitor. And what that should do is reform the plate very gently as opposed to the kaboom when you plug it in. You know, here, hold my beer and watch this type of moment. Here goes. 600 volts, test mode here, Simpson 260, watching the voltage. And we're going to start with the 6 milliamp leakage scale here. This control over here sets the voltage, and what we're going to do is slowly keep this under 6 mils. Whoop, there we go. And what's going to happen is, hopefully, as this current drops, the voltage over here is going to go up. And what's going to happen is we're going to have less leakage as the capacitor plates, they are reformed. So right now we're 500 volt scale. Oh, 250. Okay, so we're about 60 volts right there, and it's climbing, which tells me that this should be dropping. You can see right there we're still about 2.5 mils. We got a long ways to go to 500 mils, folks. It's going to take quite a while, and hopefully it does it. If not, if it goes kablooey, it's a controlled kablooey here, and it'll be a slow release of heat and a slow breakdown as opposed to all sorts of non-limited current and electrolytic paste everywhere. But let's run this up a little bit now. We're sitting there at 2 milliamps. Let's run this up to 4 approximately. And there's 4. If we go up here, there's our trusty Simpson 260. And right now it looks like, let's see, 250 mil scale down here, 250 volt scale, I should say. And right now there's 100, 125. So see, we're going up to 130 volts here. So we're slowly working our way up. This is going to be a kabuki dance, where what you're going to do is very, very carefully set the current over here if you have the voltage control. And then as this comes down, you're going to run it back up again and down and up again and down and up again until hopefully you get to 500 volts up here. When you get to 500 volts, you're done at that point. We actually have two separate plates on this one, two separate capacitors in the same package there. So we'll try the other one afterwards. We'll figure out roughly how long this is going to take. I'll let y'all know that.